Hello everybody and welcome to the first of many tutorials for EasyC V5 for VEX EDR. Today we're just going to cover the basics of EasyC and all the stuff you need to know and whatnot. But before we can do that, we must first ask ourselves, what is EasyC? EasyC is a simplistic way for young students to program their VEX robots without any sort of prior knowledge of programming, which helps to get rid of the uneasiness that comes with the task of learning to program. It uses a very simple diagram format that's very user-friendly, and it's just very simple to understand. And so yeah, all right, let's start. When you first start off the program, you're going to end up on this screen, which is your start page. From here, you have your projects. Over here, you have your recent projects. These show all the projects that you've opened recently, so anything that you've been editing. So just you can open it like just a normal program, or down here you can open new programs or open an existing program that is not on your recent page. Uh, you will notice that it says new standalone versus new competition. A competition has an autonomous and an operator controlled timed period, which you can determine that it'll run autonomously for a set amount of seconds, so that being 1 minute, which is standard for a VEX match, and a random number for operator control, so I just use 10,000 because indefinitely. And then you'd plug in your autonomous page and your operator control page. Or you can choose new standalone, which will just ask whether you want a joystick project or an autonomous project. An autonomous only project means there is no joystick capabilities and no manual control, so everything your robot do must be 100% autonomous. A joystick allows for autonomous, however, there is the capability of a joystick, of joystick commands and manual operator control. And this can be changed at any time throughout your project, so I generally just choose joystick to start. And then further down in our start page, we have our tools, which can be found up here on your normal toolbar like most programs. A help section, which is just going to bring you to the EasyC V5 help page, or the navigator as they call it, which has a lot of the more technical stuff. Things that you're probably not going to use if EasyC version 5 is your first time using EasyC, and then a list of tutorials that you can open, that in case you just want to check up on something that I don't cover. For now, we're going to open a new standalone, a joystick project, and hit OK. So now we go to this page. This is our main. This is our main page, and from there we have all of these different crazy windows, and I will explain them for now. This main window is our function page. This is where all of our programming blocks are going to fit together like a puzzle, and how we're going to have these kinds of commands. Over here we have our project explorer, which can change our config, which is in our project, as well our globals, which is also in our function window. And then the most important thing you will find in the project explorer will be this readme.txt. This will be used for providing information for other groups if you were to maybe give out this program at, say, a competition to ask for constructive feedback or their opinions, or just maybe to help them out, or to help teach them how to program if they're not as good as you. What I usually start off is with a basic descriptor of what this program is intended to do. So here we're just going to put basic program for teaching. All right, and then underneath in the bar after it, I put written by, and then you would put in the carrots your name. I'm just gonna put, I don't know why I put a B. My name, and then close, and then underneath I usually put an email. So just a generic email that you're gonna check every now and then. And this is just so that people can contact you and actually give you feedback. Uh, Feel free to email me at that email if you ever need help with anything. All right, we're going to go back down here onto this page, and you can just close this readme.txt at any time. It'll ask to save. Just hit yes. Now we're back here. We have our output and tasks window. What this window is going to do is it's going to, while you are building and downloading the program that you write up here, for your robot, or putting it into your robot, this will tell you if there are any errors or if the build was successful. And if there are any errors or anything that might cause the program to not function as intended, it will tell you so that you can find them. And if you have that, if there is an error, it'll highlight it in red, and if you double click it, it will highlight the block up here. See how that area is highlighted like that? It will highlight it so that you can find it and maybe look at just that specific bit, which is incredibly helpful. Over here we have our function blocks window, and what this does is it's all the building blocks for our program as we would put them in to our thing, and this is how you would build on your program and just put and just how you would build upon your program. That's just random information that would probably not even work. Some of the program flow is one of the program flow inputs and outputs are going to be the three you're probably going to use the most commonly for just basic programming. Once you get into autonomous, you'll be looking at smart tasks and user functions a lot. Joystick will be your operator controls, and you'll maybe use integrated motor encoders on your actual worlds competitions if you go to VEX Worlds. Battery, mathematics, LCD, those each have their own purposes. Obviously, here, the LCD display screen, I've never even used one of those. Battery, you can determine how much battery life you have. Mathematics, you can just use for finding values. I've never once used mathematics for anything except for the random number in the miscellaneous, but that's about it. All right, so let's talk about your program flow now. The first thing I do when I open a program is, well, first off, I save it. File, save project as. I choose where I want it to go. Right now, I just have it set to my directory to be on a file on my desktop called random test programs, but you can change that. It will default to a projects page. I don't like having my files there just because I lose too many files. I like having them all on my desktop. And then you're going to enter your name. You cannot use spaces in this. You have to use an underscore, and a period will also cause it to not work. So this is a very basic program, and you want to use a descriptor that is accurate to what you're going to do. So basic teaching program underscore program. And then what I usually do is I use v1, and then every time I save it, instead of just saving it to this copy, I go v2 or v3, v4. And what this does is it helps if I were to maybe do something that would screw up my entire project, which happens on occasion. I don't lose all of the progress. I just roll back a day or two and then start over from there, and I lose very minimal progress. Which obviously, as an engineer, your job is to be efficient, and not losing your work is efficiency. So, basic teaching program v1. Okay. After I name my program and I save it, I will go to my controller configuration, which I can grab from my Project Explorer, which, by the way, you can just kind of, for these, you can arrange them however you'd like. I just pin these two to the side and pull them out as I need them. That way I just don't have all these ugly windows surrounding my screen, and I can focus more on the programming. I wouldn't advise it for function blocks just because you use them so often. I start with the configuration, which will bring you to this screen right here, which looks kind of scary, admittedly. From here, the main function of this page is to define your integrated motor encoders, as well as your input and output ports, which you can switch by just clicking on the diagram where there is a connector. If you look and see how the arrow switches sides, that's input versus output, these being output, these being input. And defining what type of integrated motor encoder is on which motor and motor port. And you can also add a description to your motors. So let's say I have a drive chain, and number 1 is my left drive, and number 10 is my right drive, because I'm using 2 wires, or the 2-wire motors that are more powerful. I can save that, and you don't have to use an underscore there, it just appeals to me. And so later on, if I were to want to output to my motor, and I'm going to drop down, let's say I want to output to my right motor, instead of having to consciously remember or look back at my robot, I just see right here in the greenish highlight that it is my right drive. And then I would obviously choose my values for all that later. Next, we have our globals, which I guess I should probably talk about variables first. A variable is just like an algebraic variable, where it's, instead of just being a single letter, it's a name. So variable, that's what we'll call this. Try to be more descriptive with your stuff. And if you can, always leave, if it says comment, always leave a comment saying what it does. Random test variable. This doesn't affect your program whatsoever, but it leaves it so that, I forgot to define my type. It leaves it so that you can know what it is later on, just like I showed you with the motors. With a variable, you're going to have this drop-down box. Usually, you'll use a unsigned integer, an integer, or a float. What a float will do is it'll round it to the nearest tenth of a decimal, which is helpful when you're using analog sensors that give you information that is accurate down to the billionth of a decimal point. That way you're not having to account for such minimalistic ranges of values, and it's just cutting off that extra bit. Or an integer, which will cut it down to 1, 2, 3, 4 to 256, random number. An unsigned integer means it can be negative. An integer means it cannot. An unsigned can also be positive. Um, you'll usually use an integer when you're using a sensor that can't go into the negatives, such as a ultrasonic, because you can't have negative space. However, if you're going with an optical quadrapture encoder, you can move backwards and it detects that backwards movement as a negative. And so that's an instance when you use an unsigned versus an integer. You can define a value here. If I were going to do an assignment, that's going to start at 0. I would put it as a 0, and every change that that variable makes throughout the program will be accounted for here. It won't change what it says, but it will inevitably change the value in the actual program. I'm not just going to leave a random variable there. I'm sorry, OCD. The globals, on the other hand, have global variables, which will be shared through all of your subroutines, because a variable here will only be on this page, versus if I were to say start a user function, add new function, this is a subroutine. If I have variable, I'm not going to leave a comment, variable, if I were to look at these variables, it's not shared. However, if I were to create a global, again, integer, global variable, it would, although it's not reflected here, I can, in my inputs, where it says retrieve to, uh, this is where you choose a variable or a global, and then if I were to need to make a conditional statement over here with that variable, it will count as a global. If global equals 1, then that would happen. And so flowchart, again, this is, okay, the way I was taught to do this, I was taught that these flowcharts are individual variables, or are individual timelines, and so flowing from the beginning to end, and every time you made a conditional statement, so while, let's say we want this to run forever, we can put 1 being equivalent to 1. One thing you need to watch out for is you do need to use double operators when doing things like equals, because that makes it so that it knows it's not less than or equal to, greater than or equal to, I put that backwards, or maybe it's not equal to, which that's what an exclamation mark equal means, does not equal, or an absolute value. That helps it determine if that is not any of those. Okay, if I were to do that, so it's going to flow down with my mouse until it hits while. If this condition is true, the while 1 does equal 1, so 1 does in fact happen to equal 1, it will run indefinitely. The only reason this would ever stop is if this condition stops being true. One way I could do that is if I had a variable here instead of a 1, and this being a 1, and at the very end I were to change the value of this variable to a 2, this variable, which now equals 2, does not equal 1, so it would continue on with the program. Something you need to be aware of, if I put, well, 1 equals 1, right there, and then I put a bumper switch, a detector for a bumper switch here, it will never read this bumper switch because it will never get past this infinite loop. Another thing as a programmer you should probably watch out for is not having infinite loops, because infinite loops are really bad for your device and can even end up breaking the cortex. I've only had that happen once or twice, but that's still a very, very costly and expensive mistake. So let's say maybe you finished with your program. What are you going to do to download it into the brain? You can hit this build and download tab and then hit build and download, or as it says up there, you can just hit F7. It'll usually say cannot locate compiler tool. Would you like to save the and then it'll ask whether it wants you to never save the changes to the program, always save the changes, or prompt to save the changes. I always choose prompt to save the changes in case I'm just testing something really quickly. That way I don't have to go and look back and make another copy of it. And you can just hit yes or no. If you hit no, it's still going to do it, or it's still going to download it into the brain, and then it'll run the program. In order to download the program, you do have to have a system plugged in, or else you'll get this failed to get VEX system info notice. I don't have a robot with me, so I can't show you actually downloading it, and I don't have my camera set up yet to do that. From here, you can also import your controller configuration. So maybe you're working on a configuration for the same exact robot that you were working on in a different program. Where's one that I can get? Browse. I'm going to just grab one off of my desktop, one that I know that I have. All right, browse. All right, there we go. So import. Yes, that automatically downloads my uh, controller configuration from that other program, so I don't have to manually type it out each time, because that would be a hassle. And then say, what if I accidentally put potentiometer here instead of here, and now I don't know where my potentiometer is at, and I'm going to be smacking myself over and over again until I figure out, oh, I'm just putting in the wrong input. From this project tab, you can also import user functions, or you can add new ones from there. I'm just going to see if I can find one off of a random program that's open. Oh, there's one. Add. And that way I just, instead of having to rewrite this entire program and as a subroutine, I can just have it again be imported into this program so I can throw it on. And this is, it'll always ask you to retrieve to, and then you don't really have to change anything here. You can comment it, do subroutine battery indicator. Enter. I didn't spell routine right. Oh well. And then from there, just have your stuff imported. Another really helpful thing that you can do with EasyC is you can print out this code or this chart and have it on a separate piece of paper to like physically print out in case you're going to put it in an engineering notebook, which hopefully I'll have a video up about how an engineering notebook is made pretty soon, within 3 or 4 days. Um, and that's incredibly helpful. And you can do that from hitting File, select and print flowchart, and then print. You can either print it directly to a printer, or you can save it as an XPS file or just a PDF or Microsoft Print to PDF. If you're running Microsoft, if you're running Mac, I don't know how to do that. I'm sure there's some way too. And then you can hit OK, and it'll print. And then from there, it'll ask where you want to send it to. Oh, so it'll ask your directory. I'm going to cancel. Do not start print job. You can also print the raw code, which you will rarely use until you start with RobotC and some of the more complex coding. Honestly, I would advise stick to EasyC. Not a lot of people in the VEX community use it, and I think it is a great tool for you to use. However, if you want to find the raw C coding, you can. Over here, there will always be a small window that you can grab and pull out. It's sometimes hard to get, and this will show your main code as just the raw coding. I don't like using it again. And so from there, you also have your tools windows, which again, you can just find over here. But I like this one because sometimes I don't remember what all of these little symbols are for. Like that could be graphic display, and I wouldn't know if I were to just try to choose it from here. And then you also have your help about this will again give you your system info. So just what version you're running. From here you can choose just a quick way to pull out your windows if you need it as well. And that's pretty much it for the basics of EasyC. So guess I'll see you all next time.